Today is 14th October 2025 and this is Edexcel Physics IAL. It is unit number 1 in which we are going to start a new chapter, that is work, energy and power chapter. So let's start its theory. The first thing, what is work? In IGCSE we have studied, sir, if we exert a force on an object and if this applied force displaces the object. This is the force which I have applied. This is the displacement which the body has covered. Then force, I'm writing the definition: when applied force displaces object. When applied force displaces object. But in exam you should not write the conceptual definition. You should write mathematical definition. And what is the mathematical definition? Mathematical definition is work is the product of force and displacement. Work is the product of force and displacement. And as we have studied turning effect of force, and in that topic we used perpendicular distance, but when we are talking about work, then work equals to force parallel to the displacement. So this displacement must be parallel. In turning effect, displacement or distance is perpendicular distance, but if you are calculating work, in work it is a product of force and displacement, but they should be in the same direction. And the unit of work is joule. Acha, if you are applying force by making angle theta, consider this is a block and this block is connected with a string, and now I am applying force, and this force is making angle theta with horizontal. And when you apply this force by a string, then you will see the object will move in this direction. So the movement is parallel to the ground, but force is not parallel. Then what should I do? Sir, we have studied resolution of forces, resolution of vector. So you should resolve this force into its two components. One of them is horizontal component, the other one is vertical component, and you can see the horizontal component is parallel to the direction of motion. The direction of motion is horizontal and the horizontal component, now it is parallel. So if I ask you what is work, then work equal to F cos theta, it is the horizontal component of force, with displacement. F cos theta, F cos theta is the horizontal component, so it is F d cos theta. बेटा उसमें आपने हमें कल बताया था कि आपके कॉलेज में वर्क एनर्जी पावर स्टार्ट हुआ, तो इसीलिए आज बेटा मैंने आपके लिए वर्क एनर्जी पावर का ही चैप्टर स्टार्ट कर दिया. ठीक है बेटा. एंड नाउ इट इज द सेकंड फॉर्मूला ऑफ टुडेज क्लास. If force is already parallel to the direction of motion, then the equation is very simple, F into d. But if force making angle theta, then we resolve into horizontal component, and the horizontal component of force is multiplied with displacement. So the second formula of today's class is F d cos theta. F d cos theta. It is the equation of work done. So work topic is completed and now I am starting energy. I am starting next topic is energy. Sir, what is energy? Energy is the ability of doing work. In IGCSE we have studied the ability of doing work is called energy. And so what is kinetic energy? Kinetic energy is the energy of a body due to its motion. The energy of a body due to its motion. It is called kinetic energy, and its formula Sir, its formula is kinetic energy is equal to half mv squared. This is the equation of kinetic energy. And what is potential energy? Sir, we have different type of potential energy. Gravitational potential energy, elastic potential energy, electrical potential energy. But right now we are starting with gravitational potential energy, in which we lift an object from ground. When you lift object in upward direction, then the object stores gravitational potential energy, and we can say the energy of a body due to its height, the energy of a body due to its height, or the energy of a body due to its position, it is called gravitational potential energy. And its equation is very simple, that is mgh. So the third formula of today's class, kinetic energy is equal to half mv squared. Fourth formula of today's class, potential energy is equal to mgh. Okay, it is all about IGCS. And now the next heading is law of conservation of energy. And we know we can neither create energy, we cannot destroy energy. Energy can neither be created nor be destroyed, can be converted from one form into the other form. So it is known as law of conservation of energy. But when we are solving a level physics question, then they do not ask these statements. They ask to apply this statement on different cases. And now I am teaching you different cases. Case number one. Case number one. If an object is falling down and there is no air resistance, if there is no air resistance, then such a motion is called free fall motion. And in free fall motion, if an object is falling down, then obviously it is losing gravitational potential energy and it is gaining kinetic energy. If an object falling down, if there is no air resistance, then it is called free fall motion. And in free fall motion, potential energy change equals to kinetic energy change. But if an object falling down and there is air resistance, if air resistance is significant, if air resistance is significant, then we change the equation, and the equation changes like this: loss of gravitational potential energy is equal to gain in kinetic energy. But there is another factor involved, that is air resistance. So we will have to do work against air resistance. And remember, work against air resistance, work against resistive force produces thermal energy. Work against resistive force produces thermal energy. Okay, so if an object falling down, then it is losing potential energy, it is gaining kinetic energy and work against air resistance. But you know, if an object falling down through air resistance, then the object attains terminal velocity. If object attain terminal velocity, we have studied terminal velocity topic in the last class. Then you know, when the object attain terminal velocity, then there is no further increase in speed. And if speed is not increasing, then there is no gain in kinetic energy. And in this case, if the object has attained terminal velocity, then gravitational potential energy loss is not converting into kinetic energy, but it is converted work against air resistance. I think it is a new concept. If object has attained terminal velocity, then there is no further increase in speed, no further increase in kinetic energy. So gain in kinetic energy becomes zero. So we erase this topic. We erase this factor and only gravitational potential energy converting into work against air resistance. And now I am teaching you the last case. It is case number 3 in which object attain terminal velocity as well as if okay, let me explain case number 4. Consider a rocket is fired in upward direction or an aircraft is moving in upward direction. You know, when aircraft or rocket is launched in upward direction, then obviously working engine in the rocket, engine in the aircraft is in working. And if engine is working, then obviously fuel is burning out. So work is done by burning fuel. If engine is working, if engine is working, then we are doing work by burning fuel. And now the rocket or aircraft is moving in upward direction. So there will be gain in gravitational potential energy. If the speed is increasing, then there is a change of kinetic energy, and obviously there is air resistance. So there will be work against air resistance. So if engine is working, if fuel is burning, then the work done by burning fuel equals to increase in potential energy, increase in kinetic energy, and work against air resistance. If speed is constant, if speed is constant, then kinetic energy change be zero. If height is constant, if height is constant, sometime an aircraft is flying at a certain height and height is neither increased nor decreased and it is moving at a same level, then obviously height is not changing. And if height is not changing, then gravitational potential energy not increasing. So you should read the question and then decide which factor should be erased from the equation. If height is not changing, then GPE should be erased. If speed is not changing, then kinetic energy should be erased. So these are 4 cases and I am asking you one by one, and I am going to ask you one by one, although I am repeating. Case number 1, sir, in free fall motion, only potential energy and kinetic energy are converting into each other. If there is air resistance, then potential energy, kinetic energy, and there is work against air resistance. If the object has attained terminal velocity, then kinetic energy should be erased. If if the engine is working, if engine is working, then work done by burning fuel, it is converted into potential energy, into kinetic energy, into work against air resistance. So you should memorize all these cases. And I am checking you, are you in class or sleeping? Ha beta Simra? Simra beta, I am asking you, if there is no air resistance, then what is conversion of energies? If there is no air resistance, then what is conversion of energies? Simra? Yeah, no air resistance, then which energy converting into which? Sir, if there is no air resistance, then it is free fall motion and there is only potential energy and kinetic energy conversion. Okay, beta? There is only potential energy and kinetic energy conversion. ठीक है बेटा? अच्छा, उसवा आप हमें बताइए, if an object attain terminal velocity, तो क्या खास बात कर देते हैं, इफ ऑब्जेक्ट टर्मिनल वेलोसिटी पकड़ ले। नहीं 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 नहीं, रुक गया। अगर टर्मिनल वेलोसिटी पकड़ ली बेटा, तो काइनेटिक एनर्जी का चेंज खत्म हो गया। जी, चेंज इन काइनेटिक एनर्जी जीरो हो जाता है, चेंज। ठीक है ना, देयर इज नो फर्दर इंक्रीज। यू नो व्हेन ऑब्जेक्ट अटेन टर्मिनल वेलोसिटी, देयर इज नो इंक्रीज इन एनर्जी, इन काइनेटिक एनर्जी। ठीक है बेटा, तो टर्मिनल वेलोसिटी अटेन कर लीजिए अगर ऑब्जेक्ट, तो काइनेटिक एनर्जी का चेंज जीरो हो जाएगा। बनीन बेटा ये बताएं, एयर क्राफ्ट चल रहा है, एयर क्राफ्ट चल रहा है, ठीक है ना, लेकिन एयर क्राफ्ट ना ऊपर हो रहा है ना नीचे हो रहा है, कौन सा फैक्टर इरेज कर देंगे? पोटेंशियल एनर्जी गायब कर देंगे सर, हाइट ना कम हो रही है ना ज्यादा हो रही है। ठीक है बेटा, जबरदस्त हो गया। अब जरा जल्दी से और आगे आइए, एक दो डेफिनेशन और पढ़ लें, देन वी शुड स्टार्ट पास्ट पेपर शीट। द नेक्स्ट हेडिंग इज व्हाट इज पावर। व्हाट इज पावर? सर पावर वी हैव स्टडीड इन IGCSE, rate of doing work, rate of energy, work done per unit time, it is called power. The unit of power is watts. The unit of power is watts. But sometimes this work is replaced by a force into displacement, and if you divide displacement by time, then it becomes velocity. So you have another definition of power. Sir, power is the product of force and velocity. You have another definition of power. Sir, power is the product of force into velocity. So you should know this formula as well. Power is work upon time, and power is the product of force and velocity. Okay. And now the last one, it is about efficiency. You know, efficiency is equal to output, useful output divided by input. The ratio between output and input, it is called efficiency. The ratio between output and input, it is called efficiency. But I am writing this formula two times. Why? Because sometimes we use output power divided by input power, and sometimes we use output energy divided by input energy. Okay, so efficiency may be power output divided by power input, and sometimes in terms of energy. Sometimes we multiply with 100 to answer in percentage. It is your choice. It is not mandatory. It is your choice. अच्छा सर, इनपुट एंड आउटपुट आर ऑलवेज इक्वल? अरे नहीं जनाब, इनपुट equal to output, it is an ideal case. Input is equal to output, it is an ideal case. Most of the time some energy is wasted as thermal energy. Sir, give me any example. Yes, I am giving you an example. Consider this is a slope, this is a slope, and its angle with horizontal is theta. Consider a block is placed at the bottom of the slope, and now you are pushing this block to move along the slope. Consider the length of slope is d, the height of slope is h, making angle theta, and you are exerting force F, and you are doing work on block by displacing d. So the input is F into d. The input is F into d. This is input. Sir, what is output? The output is the block has lifted to this point. So sir, what is output? The output is gravitational potential energy. The output is gravitational potential energy. But when you push block on the slope, then obviously there must be force of friction on the slope, on the inclined plane. So some energy will be wasted in doing work against friction. Against friction, against friction, some energy is lost. So input you are doing, sir, you are applying force, the object displays D, you are doing work on the block. The block is moved upward on the slope and its output is mgh, and there must be some energy is lost as work against friction. So it is an example in which I have shown sometime input is not converted 100% into output and some energy is wasted as doing work against friction. So it is the theory of this chapter, and I think most of the topics we have studied in IGCSE, it is not new one. So theory is completed and theory is not difficult. Theory is not difficult, but when you solve past paper questions, then you will find a lot of variety. Now let's start past paper questions. And I think we should start with from PMT sheet. This is the PMT sheet. And in this PMT sheet, we have solved this kind of question in the momentum sheet. Yes. And I think in this question, they are asking calculate power. Calculate power. Okay. We have to calculate power. Sir, what is the formula of power? Sir, we have a formula of power. Power equals to work upon time or energy upon time. Sir, time, yes, time is given 17.5 second. I think it is a time. Okay. But we are not given energy. And how do we calculate energy? Let's try to solve it. Let's try to solve it. So read the question carefully, then we will solve it question. In the sports of curling, two teams of curlers take turns sliding, pushing. Acha, the first paragraph is Fuzul. And now, a stone of mass, you are given mass, it is accelerated uniformly for 1.25 seconds. So we are given two times. I do not know which time I will use to calculate power. Okay. A stone of mass 19.6 kg is accelerated uniformly for 1.25 seconds before being released by curler. The stone then decelerates uniformly to rest, traveling 32.5 meters in a time of 17.5 seconds. Okay. Calculate useful power developed by the curler in accelerating the stone. Okay. So what is the meaning? The meaning is, if you read the question, the question is, the player is called curler. Okay. And this curler accelerates accelerates the stone. Okay. The curler accelerates the stone, and when he accelerates, the acceleration time is 1.25 seconds. Okay. The curler accelerate the stone for 1.25 seconds. First he accelerates, and when he accelerates, then he released the stone. And when he released the stone, I do not know what will be the speed of the stone when he released. Okay. First he accelerate. मुझे नहीं पता कि आपने ये गेम देखा हुआ है या नहीं. इस गेम में हो क्या रहा है? सर, ये स्टोन है. इस स्टोन को कर्लर लेके भागता है, पहले एक्सिलरेट करता है. एक्सिलरेशन टाइम इज 1.25 सेकेंड. ठीक है. एक्सिलरेट करके, ठीक है जनाब, एक्सिलरेट करके रिलीज कर देता है. ठीक है. जब रिलीज कर देता है, तो नाउ this stone is moving forward, the stone is moving forward, or now when he released, then obviously stone begins to decelerate and finally come to rest. तो स्टोन ने फाइनली रुक जाना है. स्टोन की इनिशियल वेलोसिटी क्या है मुझे नहीं पता, एंड द टाइम टू डिसेलरेट द स्टोन इट इज 17.5 सेकेंड. ठीक. तो यू आर गिवन टू टाइम्स एंड आई थिंक यू शुड कंफ्यूज इन दीज टू टाइम्स. एक टाइम है 1.25 सेकेंड, एक टाइम है 17.5 सेकेंड. सर दिस इज द टाइम इन विच द कर्लर moving stone producing acceleration, and after producing acceleration he released, and when he released, by pushing, by acceleration, when he released, now the stone begins to decelerate, and the deceleration time is 117.5 second. And I think if I draw a graph, then I can explain you better. The explanation is, this is the time, this is the time in which velocity is increased. This time is 1.25 second in which velocity is increased, and this velocity is increased by curler, and then he released the stone. Then you can see its velocity is decreased, and deceleration time is 17.5 seconds. So first I think I have cleared the difference between the two time. उसवा बेटा मुझे बताइए, ये 1.25 सेकंड कौन सा वाला टाइम है और 17.5 सेकंड कौन सा वाला टाइम है. उसवा जल्दी से बताइए. हाँ बिल्कुल. एंड दिस एक्सीलरेशन इज प्रोड्यूस्ड बाय कर्लर. ठीक है. कर्लर इज द पर्सन. ओके. कर्लर इज द पर्सन, एंड दिस इज the deceleration when the object is released. ठीक है जनाब. so we have to calculate the power of curler. ठीक है. we have to calculate power of curler. हमें कर्लर की पावर कैलकुलेट करनी है. ठीक है जी. अच्छा जी सर, हाउ डू वी कैलकुलेट. सो द आंसर इज, सर कर्लर पावर इज इक्वल टू कर्लर वर्क डिवाइडेड बाय कर्लर टाइम. सर टाइम इज क्लियर for curler. So time is 1.25 seconds. Curler time is 1.25 seconds. Okay. Sir, what about work? Sir, work is force into displacement. Force into displacement. Okay. Sir, what is force? What is force? I am calculating work. Sir, what is force? You know, when the curler released the stone, release release the stone, then the stone is moving, and you know when stone is moving, then work equal to kinetic energy, and kinetic energy is equal to half mv square. Kinetic energy is half mv square. Okay. Or you can solve this question by force into displacement as well. So displacement is 13.32.5. It is the displacement. So what is force? Force is equal to m into A. M into A. What is the mass? Sir, mass is 19.6. I'm calculating force. 19.6. Sir, what is velocity? Acceleration. Sir, acceleration is V minus U upon T. V minus U upon T. But the issue is, we do not know. We know the final velocity is 0, but we do not know what is initial velocity when the ball was released. When the ball was released, we do not know what is the speed. So we cannot solve this question without calculating u. Sir, how do we calculate u? So I am explaining you. If you use this formula, distance is equals to half u plus v into time. Okay, when curler released the stone has covered distance of 32.5. Yes, curler has covered 32.5 displacement. Sir, half is a constant. Yes. Velocity, when curler released the stone, I do not know what is the velocity. It is u, but final velocity is 0. And how long it takes to come to rest? Sir, this time is 17.5 seconds. So you should calculate u, and this u is the velocity with which the curler released the stone, and this velocity is 3.71 meter per second. If you calculate this u, then this u will be 3.71 meter per second. Okay, and when you have calculated u, then I am using equation of kinetic energy. Remember, work and energy having same meaning. Work and energy having same meaning. Now we have calculated the velocity. So now I can calculate power. Sir, power is equal to half the mass of a stone. It is 19.6. Velocity 3.71. Time 1.25, and if you divide all the numbers, then the power is 108 watts. और बनीन आपको याद होगा, मैंने पहले भी एक दफा आपको ये बात समझाई थी कि सम टाइम वी डिवाइड द क्वेश्चन इनटू टू सेगमेंट. In this question B, there are two segments. Segment number one, when the curler is accelerating the ball. When the curler accelerating the stone, it is stage number one. And for this stage number one, you have to calculate the power of curler. But when he released the stone, it is segment number two, in which the stone has covered 32.5 meter distance. Its final velocity will be 0. The time for deceleration, it is 17.5. So when the curler released the stone velocity was 3.75. And this velocity is generated by curler. Okay, and this velocity produces kinetic energy. So equation of kinetic energy is half mv square. Half is constant, mass is 19.6, velocity when the stone released, it is 3.71, and we are calculating power of curler. So the time is 1.25 seconds, and if you divide energy by time, then the power is 108 watts. Then the power is 108 watts. Allah, the question is not simple. अच्छा जी, मैं एक आखिरी दफा रिपीट कर रहा हूँ और मुझे उसवा समझाएंगे क्या हुआ. उसवा बेटा गौर से सुनना. सर, इन दिस क्वेश्चन there are two segments of the question. In the first segment, the curler is accelerating the stone, and this is the time 1.25 seconds in which he is accelerating, but we have to calculate power of curler. So we will use kinetic energy divided by time. Kinetic energy half mv square, time is 1.25, but we do not know what is the speed of the stone when it is released. We do not know the speed of the stone with which it is released. So first we calculated the speed at which the stone is released by using this equation. Distance is equal to 32.5, half is constant. Initial velocity when the ball released, we have to calculate. Final velocity will be 0. Stone come to rest in 17.5 seconds. So we have calculated the velocity with which stone is released, and this speed is used to calculate kinetic energy, and energy divided by time, it is power. बेटा उसमें मैं कुछ भी नहीं बोलूंगा, आप जो भी बोलेंगे मैं चुपचाप से सुन लूंगा. जो भी आपकी समझ में आया वो आप मुझे बताएं, उससे मुझे आइडिया हो सकेगा कि आपको मेरी बात समझ में आई या मैं अकेले अकेले बोले चला जा रहा हूँ. जी बेटा उसमें कुछ भी बोलिए. हम्म. हम्म। बहुत अच्छा, बहुत ही अच्छा आपने समझा दिया। इसका मतलब आपको पूरा बेहतरीन समझ में आ गया है। और बनीन बेटा आपको भी, क्योंकि मैं आपको इसलिए स्पेशली एड्रेस कर रहा हूँ कि जब मैं आपको मोमेंटम वाला टॉपिक पढ़ा रहा था वहां पे भी आप बोले थे सर ये दो सेगमेंट का क्या चक्कर है। तो इस क्वेश्चन में भी बात समझ में आ रही है बेटा बनीन, कि जो कर्लर है वो स्टोन को लेके भाग रहा है। जब वो लेके भाग रहा है इट इज द फर्स्ट सेगमेंट ऑफ द क्वेश्चन, ठीक है ना। जब कर्लर उसको एक्सेलरेट कर रहा है, फिर कर्लर ने उसको छोड़ दिया। जब उसको छोड़ दिया तो वेलोसिटी नहीं पता, कितनी वेलोसिटी से छोड़ा ये नहीं पता, ठीक है। उसी वेलोसिटी से वो डिसेलेरेट होता 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 तो जीरो हो गया, ठीक है ना। तो हमें ये वाली वेलोसिटी कैलकुलेट करनी थी। अब ये वाली वेलोसिटी कैलकुलेट करने के लिए हमने एस इज इक्वल टू हाफ यू प्लस वी से पहले वेलोसिटी निकाल ली, उसी वेलोसिटी से काइनेटिक एनर्जी निकाल ली। तो क्वेश्चन में मैं काफी टाइम लगा चुका हूँ एंड आई थिंक आई शुड मूव फॉरवर्ड। नाउ द नेक्स्ट क्वेश्चन इज, ये क्वेश्चन इतनी लंबी स्टोरी दी हुई है इन्होंने, ठीक है जनाब, बहुत लंबी स्टोरी दी हुई है। आप पूरी स्टोरी अच्छी तरह से घर पे जब कभी फ्री बैठे हो तो पढ़िएगा, ठीक है। काम की बात यह है कि जब एरोप्लेन फ्लाई करता है, ठीक है जनाब, तो उसकी हाइट है 8500, सही जनाब। ये दिन के टाइम की बात हो रही है। और जब वो रात होती है तो वो नीचे आ जाता है, ठीक है जनाब। दिन के टाइम में इतनी हाइट पर है, रात के टाइम में इतनी हाइट पर है, ठीक है ना। क्वेश्चन इतना सा है, व्हाट इज चेंज इन ग्रेविटेशनल पोटेंशियल एनर्जी, व्हाट इज चेंज इन ग्रेविटेशनल पोटेंशियल एनर्जी। आप पूरा क्वेश्चन आराम से पढ़िएगा। आई एम सॉल्विंग, इट इज अ 2 मार्क क्वेश्चन। कभी भी देखो ना, 2 मार्क का क्वेश्चन है, 1 मार्क का क्वेश्चन है, समझदार ये स्टोरी इतनी लंबी बिला वजह सुना रहा है, हमें तंग कर रहा है। काम की बात इतनी सी है कि जनाब वो पोटेंशियल एनर्जी का चेंज पूछ रहा है, ठीक है जी। और इस पोटेंशियल एनर्जी का चेंज कैलकुलेट करने के लिए आई नीड मास। तो बेटा जरा कोई बच्चा ढूंढ के बताया आपको कहीं मास नजर आ रहा हो इस एरोप्लेन का मास ये रहा जी, 1600 kg मास है। मास 1600 kg है, ग्रेविटी 9.81 है। हाइट का चेंज, हाइट का चेंज सर, एट डे टाइम it is 8500, at night time it is at a height of 1500, and if you solve these two numbers then you can calculate change in gravitational potential energy, and it is 1.1 exponent 8 joule, it is 1.1 exponent 8 joule। तो क्वेश्चन बहुत सिंपल है, स्टोरी उन्होंने बहुत लंबी लिख के दी हुई है, ठीक। दलीजिए बेटा अगर कॉपी कर रहे हैं तो नोट कर लीजिए। नाउ अनदर क्वेश्चन। सर ये तो मुझे वाला टॉपिक लग रहा है कोलिजन का, जी हाँ शुरू में तो ऐसे ही लग रहा है। कह रहे हैं जनाब, बम्पर कार ट्रैवलिंग 7 मीटर पर सेकेंड कोलाइड विद अनदर बम्पर कार स्टेशनरी, ठीक है बेटा। दिस इज मूविंग विद 7 मीटर पर सेकेंड एंड दिस इज स्टेशनरी, सो दिस इज टोटल मोमेंटम बिफोर कोलिजन, ठीक है जनाब। एंड एज दे कोलाइड they move off together after the collision. If they are moving together, then their masses are added. 300 plus 250, it is total mass. And calculate final velocity after collision. So you have to calculate final velocity after collision. बहुत ही मासूम सा क्वेश्चन हमें लग रहा है, आईजीसीएसई स्टैंडर्ड का है कि वन कार इज मूविंग, other car is stationary. After collision, they stick together, so their masses are added, and we are calculating their velocity after the collision, and this is 3.8 मीटर पर सेकेंड। तो बहुत ही सिंपल फर्स्ट पार्ट था, जल्दी से मैंने बेटा कर दिया। सेकंड पार्ट में देखिए, क्या आपको तंग करते हैं? द क्वेश्चन इज, आफ्टर ट्रेवलिंग 1.3 मीटर the cars come to rest. It means after collision. This is initial velocity 3.8. Come to rest, final velocity 0. Distance covered 1.3 meter, and you have to calculate force of friction. You have to calculate force of friction. You have to calculate force of friction. ठीक है ना? आपने force of friction calculate करना है. You have to calculate force of friction. ठीक है ना? सर हाउ डू वी कैलकुलेट फोर्स ऑफ फ्रिक्शन? तो सर फ्रिक्शन का फॉर्मूला होता है, फोर्स का फॉर्मूला होता है F इक्वल टू एम ए. ठीक है ना? F इक्वल टू एम ए. सो यू कैन सॉल्व दिस क्वेश्चन बाय F equal to ma. Okay, you are given mass. Yes, we are given mass. After traveling, after collision they are moving together. ठीक है जनाब, they are moving together, so we will use combined mass. 300 plus 250, sir, it is 550. It is 550, but we do not know acceleration. We do not know acceleration. ठीक है ना? एक्सेलरेशन नहीं पता. सर एक्सेलरेशन के लिए टाइम चाहिए, टाइम नहीं पता. सर बगैर टाइम के एक्सेलरेशन आ सकता है if we use this equation 2as equal to v square minus u square, and now you can calculate acceleration. You can calculate acceleration. Sir, final velocity will be 0, initial velocity 3.8, 2 is constant, and distance is 1.3 meter. So first you calculate acceleration, and when you calculated acceleration, मेरे पास इसका आंसर लिखा हुआ नहीं, कोई बच्चा मुझे बता दे. 3.8 square divided by 2 into 1.3, and this deceleration should be used here. Sir, force is 550, deceleration is 5.55, and this minus means it is force of friction. You know friction is always in opposite direction, so you can write minus. You can write minus. So this force will be negative. हाँ बेटा कितना आ रहा है? ठीक है बेटा, सही लिखा है मैंने? ठीक है बेटा, 3052. ठीक है बेटा. अच्छा बेटा, the same question I am giving you another method. In the first method, sir, I use formula F equal to m into a. Mass is given, but acceleration is not given. So first we calculated acceleration by using third equation of motion, and this acceleration is used to calculate force. The question is done, but I am interested to solve this question by another method. The method is, you should know, work equal to kinetic energy. Work equal to kinetic energy. Sir, work equal to force into displacement. Force into displacement. Displacement is 1.3, and friction is doing work to control kinetic energy. So we have to calculate force, work, displacement is 1.3. On the other side, sir, kinetic energy is half, mass. Mass of combined car is 550 into velocity. Sir, velocity is 3.8. Sir, velocity is 3.8. So if you calculate force by this calculation, then again the result will be the same. It will be 3052 Newton. The same result you will get. So you can solve this question by either method. Work equal to kinetic energy. Work against friction equals to kinetic energy. Work equal to force into displacement. Kinetic energy is half mv square. So you can solve by this method as well as F equal to ma. And now the next part of the question, which is 1 mark question, state one assumption made in order to carry out calculation. Whenever two objects are making collision, then we assume there is no external force acting on the system. This is the assumption. Whenever two bodies are making collision, we apply this assumption, no external force acting on the system. Okay. And now again I am repeating कि जब आप फिजिक्स में थ्योरी पढ़ते हैं तो थ्योरी इज वेरी सिंपल, बट व्हेन यू सॉल्व पास्ट पेपर क्वेश्चन तो तारे नजर आ जाते हैं. So if you solve too many questions from past papers, then you will be able to attempt yearly past papers. ठीक है जी. लेकिन if we do not solve these questions and start past paper yearly questions, it will be very difficult. Tomorrow at the same time, we will continue this sheet. And now I am stopping recording.